So we're now working on Chapter 6, in which we cover the normal distributions. This is in some ways a big shift from the last chapter, because in the previous chapter we were working with discrete distributions, which, if you recall, means that each individual outcome could be counted, right? So in order to find the probability of each outcome, we just needed to find the exact value, and we could find its probability of occurring, or the probability mass of that outcome. Now, with continuous distributions, we don't have that same benefit. Where instead, as we'll see, if x takes on a specific value, that really is meaningless, because any one value out of the continuous range of possibilities is not likely to occur. However, to motivate what we're actually doing here, I think it'd be best if we think about a myth that is debunked in some circles, but in others it remains stubbornly popular. So what we think about popularly as IQ is a concept of being able to measure human intelligence. So the idea originally was that IQ was meant to measure intellect, but as we've found out in the past century, and actually much earlier than you might think, there are not one way of measuring intellect, and in fact, there are many ways of categorizing intellect itself. So what the popular view is that there's a bell curve of humanity where a large amount of people sit near the mean, an IQ of 100. In fact, that's the way it was designed. So mean IQ is 100. And so roughly somewhere around 68% of people are no more than 15 above or below that. So our standard deviation here is 15. And this is what's considered, or what was considered under this framework, as the normal range of human intelligence. You move out another standard deviation, and now all the people that lie in between these are now considered usual. So anywhere below that, below 70 IQ and 130, it should be symmetric. My apologies. No. Anyway. And you have a stubborn classification that was actually used historically to justify all sorts of atrocities. If you are curious about the consequences of the IQ framework, I recommend you look up from the University of Virginia their historical collections on the legacy of the Buck v. Bell decision, which upheld the right of the state to sterilize people who were deemed unworthy or unfit to have offspring on account of having too low of an IQ. Fortunately, we are, at least with respect to IQ, more civilized, in that we understand that that's not a proper way to evaluate someone's intellect, much less their worth. And just like this bell curve idea is applied to intellect, it's applied to all sorts of other positive human characteristics. And so whenever you encounter somebody who is a proponent of this idea, at least in the sense of everybody falls onto this bell curve in terms of beauty, intelligence, other desirable qualities, just be mindful that it's possible that these people have ideas derived from eugenics. In other words, they're eugenicists, or those who believe that certain characteristics or races should be eliminated from the human gene pool. Very, very big yikes. So with that said, that means that IQ is not something that we're actually going to explore in this class, but historically we should at least address the fact that the power of statistics has been used for evil. That said, we are going to learn about working with normal distributions, and specifically what we're going to learn is how to work with, in particular, normal probability distributions. So we're going to learn how to determine, analyze these distributions. So when do they arise? What are their means, standard deviations? How do we calculate probabilities using them? How do we find percentiles? What's a low and unusual outcome? What is a significant outcome? And so on. With this, and with a few other associated distributions as well, we're also going to determine and analyze sampling distributions. So when we want to systematize the concept of random sampling and to find out what happens to statistics as we take larger and larger samples, then we'll invoke the power of sampling distributions, which is thinking of each as a continuous random variable. And that'll allow us to make predictions that are especially powerful for the future chapters of this course. We'll learn to assess a data set for normality. So in other words, given some sample data, how well does that fit our normal distribution model? Can we fit a bell curve to it, essentially? And we'll apply the central limit theorem, which is a very celebrated result in statistics that tell us that the larger the samples that we take, no matter what the underlying distributions are for these samples, that the means are going to be normally distributed. So in other words, bell curves arise in many, many, many more situations than we would naturally think of. And so for this reason, we are so interested in the normal distributions, and we will cover these objectives.